Welcome to the World Computer Tech Talks. My name is Sam and I lead the engineering team at the DFINITY Foundation. One of the most fundamental ideas making crypto and Web3 possible is decentralization. But what is decentralization? Why does it matter? Why is it more than having a set of arbitrary machines running a replicated ledger? The goal of the world computer is to give people complete ownership and control of their entire digital life. This includes crypto tokens as a means to transact value, their digital identity, data, and computation. To achieve that, we require a compute and storage platform that is extra secure and resilient. There must be no single point of failure. That includes no single point of trust. Let's see how this can be accomplished. By replicating computation and storage among many machines, the error tolerance is increased and the risk of data loss is reduced. But let's assume all these machines are controlled by a single party. In that case, we still have a single point of trust as a single point of failure. In other words, replication alone is not sufficient. We want to make sure that the machines are controlled by different, independent parties. We want them to be decentralized. How can we be sure that the machines are truly decentralized? How can we be sure that they are really controlled by different parties? Most crypto protocols allow anyone to run machines. That leads to large numbers of machines. The parties running them remain somewhat anonymous. Because it is prohibitively expensive to run a large set of machines, the community assumes that there is no single party controlling a relevant subset of machines, and hence there is no single point of trust. This approach requires a lot of resources, including a lot of energy to run all those machines. ICP follows a different approach. We call the parties controlling machines node providers. The ICP community votes on node provider applications. As part of their application, node providers reveal their identity, which gives the community higher assurances in terms of decentralization. No excessive amount of machines is required because there is no need to rely on large numbers. We call this approach Deterministic decentralization. This makes ICP the most resource and energy efficient protocol. Let's look at the ICP topology in more detail. The Internet Computer Protocol is run by more than 1,000 machines distributed across all continents and operated by more than 100 different node providers. Node machines are grouped into shards called subnets. By adding more subnets, ICP can scale as usage increases. The size of subnets varies depending on the sensitivity of the smart contracts running on them. Regular application subnets are composed of 13 machines. The largest subnet is composed of 40 machines. Thanks to deterministic decentralization, the ICP community can be sure that every machine in a subnet is controlled by a different node provider. Decentralization is not only about who controls the machines. There are additional areas of control that require decentralization to achieve the promise of the world computer. One of these areas is governance. ICP is constantly evolving, which requires a lot of decision making. For example, I just explained that the community needs to decide who is allowed to become a node provider. But how are these decisions made and implemented in a decentralized fashion? ICP is controlled by a DAO called the Network Nervous System, NNS. Network topology changes or protocol updates are executed by the NNS. There is no middleman that executes these decisions by hand. Code is the law. It's literally the DAO itself that runs the smart contract that performs these changes. Community members can stake the ICP token to gain voting power and decide on NNS proposals. In 2024, the NNS voted on almost 8,000 proposals. That's more than 20 proposals per day on average. The protocol was updated more than 100 times last year. Because not all community members have the time or knowledge to review all these proposals, they can follow other voters instead. This is called the concept of liquid democracy. Another aspect to cover when talking about decentralization is who controls the communication channel between a user and the protocol. On one hand, users shall not be forced to trust a single entity when interacting with ICP. On the other hand, interacting with the protocol shall be user-friendly and not require special software. ICP addresses both needs. Because ICP smart contracts can serve web assets such as HTML and JavaScript, users can load frontends and interact with ICP with their regular web browser. Multiple parties run machines that translate these HTTP requests to RPC calls. They are accessible through different domains, which avoids the need to trust a single party. This gives users the power of choice. Now that we have covered the main decentralization aspects of ICP, you may wonder who controls the smart contracts running on ICP. Multiple decentralization solutions and frameworks are available addressing different needs. The most simple solution is to remove every controller from your smart contract. Nobody can then change or delete the smart contract. In other situations, control shall be distributed among a set of known parties. For this use case, multisig control frameworks are most suitable. For example, the Orbit framework allows such control policies. If the control of a smart contract shall be in the hands of a community, then DAOs are the most common solution. Different DAO frameworks are available on ICP. The Service Nervous System, SNS, is a popular framework that is dominating DAO ranking charts, demonstrating the strength of this governance solution powered by ICP. This overview shows that decentralization has many dimensions. Ultimately, ICP relies on an active community, and there are many ways to become active yourself. Stake some ICP tokens to vote on NNS proposals, or become a node provider to run your own node machine. Join us in our journey towards the world computer.